In lesson 5.4, we're going to talk about how to solve systems of two linear equations in two unknowns by using determinants. And to begin with, we're considering the two basic equations that are given here. So on your screen here, if you'll notice, we have one equation here with a sub 1 x plus b sub 1 y equals c sub 1. That's an equation in the form ax plus by equals c. And a sub 1, b sub 1, c sub 1 are just numerical values. And then we have the second equation here, which is a sub 2 x plus b sub 2 y plus c equals c sub 2. So these are our two equations and our two unknowns, the x and y's being unknowns. And notice what we're going to do with that. So we take the first equation and multiply by b sub 2. So when we do that to the first equation, this is what we end up with. We end up with this. And then we're going to take the second equation and multiply it by b sub 1. Okay, so in the second equation, b sub 1, so that gives us this equation. And then to solve these two equations, we're going to solve for x and then y. So to get x by itself, what we need to do is move the b sub 1, b sub 2, y to the other side of the equation, and then divide both sides by a sub 1, b sub 2. So eventually, this is what we end up with. The solution for x is this. So this is what x is equal to. And then the solution for y ends up being this fraction. Now, to describe these fractions here, we have a shortcut form. And the shortcut is if you'll notice here in both of these, the denominators are a sub 1, b sub 2, minus a sub 2, b sub 1. That's the denominators in both of these fractions. Well, a shortcut way of writing that is as a determinant. And a determinant is just simply a rectangular array here, a square matrix that is enclosed by these two vertical bars. And the way you calculate the value of a determinant is you multiply the a sub 1 times b sub 2, and then you subtract a sub 2 minus a sub 2 times b sub 1. That's this other cross product as it's demonstrated here. Okay, so we're going to be using determinants to solve systems of two equations and two unknowns. So our example problem is this one over here on the far right. Solve this system by using determinants. X plus y equals 3, 3x minus 2y equals 14. Now, we've already talked about other ways to solve this system, but we're going to use this technique using what's referred to as Cramer's rule. And Cramer's rule says that the value of x is the quotient of these two determinants, and the value of y equals the quotient of these two determinants, provided that the determinant in the denominator is not equal to 0, because we can't be dividing by 0, right? So it's important to know three things about these determinants. First of all, if you'll notice here for x, this first determinant here, for our value of x, the numerator is an array in which the first column are the c values. Notice up here c1, c2, and the second column are the b values. Okay, and we have this rectangular array, this 3, 14, 1, negative 2. And then our denominator is just the coefficients of the two variables, x and y. So that's 1, 3, and 1, negative 2. But the numerator, we replace the first column with 3, 14. And then in the y, the denominator is the same. It's still the coefficients of the x and y values, but we replace the second column here with 3, 14, the values of c. And then when we do the calculations and we solve, we find out that x is equal to 4 and y equals -1. Now, what I'd like to do is show you how to do this on the calculator. Okay, so looking at this system with the calculator in hand, we're going to see if we can figure out our values for x and y. Now, this is a determinant, a 2 by 2, so it starts out as a matrix. So in our calculator, right above the x -1 in blue, you'll notice that's matrix. So we're going to press second, matrix, and we have 3 tabs across the top here. One is the names of the matrices. The second tab, if I arrow over, is doing some calculations with those matrices. And the first one here is finding the determinant. And if we arrow over one more time, we're at edit. So I want to edit matrix A. So I'm going to key enter. And this matrix is 2 by 2. That means it's 2 rows and 2 columns. So 2 by 2. Hit enter. And this is the numerator on that x. So this is going to be 3, 1, 14, -2. Okay, so that's matrix A. I have that in my calculator. So now I'm going to quit this. Second mode is quit. And I'm going to go back to my matrices. So second matrix. And I want to edit another matrix. So the denominator for this thing, we're going to call C. Let's look at the Y first. We'll call that matrix B, the numerator in Y. So we're going to create a 2 by 2. And these are our coefficients that we're using, or our constant term, constant and coefficients for Y in the numerator. So this is 1, 3, 3, 14. So that gives us matrix B. And we're going to quit that one. So second, quit. And then for our final one, second matrix, we're going to go over and insert a matrix C, which is a 2 by 2. And that's our denominator for both of these. So that's 1, 1, 3, -2. And we're going to quit that. So then now we need to do the arithmetic. We need to take the determinant of, and the way this looks is back over here in this problem, matrix A is the numerator on the x. So we're taking the determinant. Let's do second matrix, math, the determinant of matrix A. So that's second matrix, and that's a name this time, matrix A, close parenthesis, and divide it by second matrix, and we're going to choose math, determinant of matrix C. So second matrix, keep going back to that, of C, and then close parentheses. Okay, so we're taking matrix A, determinant of matrix A, divided by the determinant of matrix C, and that gives us 4. So our answer for x is 4. And then I want to do just the same thing again, except this time with matrix B. So I'm looking at the determinant of matrix B, close parentheses, divided by the determinant of matrix C, close parentheses, and that gives us -1. So our solution to this problem, back over here in our problem, is going to be x is equal to 4. When we evaluate the determinant of this, divided by the determinant of this, and y equals -1. So that means we have 2 lines and their point of intersection is at 4, -1. And that's using Cramer's rule.